Okay, today's video is going to cover lesson 5.1, factoring binomials. The goal today is to use the distributive property to factor out a monomial from a binomial. So we're going to try to factor out one thing from two things. Mono is one, bi is two. Don't let the words confuse you if you don't have them memorized. Just one key term today, and it's the distributive property. So you're already thinking, well, I already know what the distributive property is, and you're right. You know that the distributive property lets you take something like 3 times x plus 2, and it lets you take this 3 and multiply it into the terms that are being added to get 3x plus 6. You know this part of the distributive property. However, it's important to note that distributive property also works in the opposite way. So maybe you're given the expression 4x plus 8. What the distributive property lets you do is it lets you factor or take out common factors of things that are being added or subtracted. So it's working in the opposite direction. So you're trying to think, okay, what could have been distributed into the parentheses to get 4x plus 8? So there's a couple things, right? You could have had originally 2 times 2x, which would give you 4x, plus 4, which would give you 8. So this would be some number that could have been factored out. We could factor out a 2 from 4 and 8. Or you could have had maybe 4 times x plus 2, because 4 times x is 4x, and 4 times 2 is 8. So we're trying to go from something like this to something like this or this. Let's get into the first example today. Example number 1. Factor the expression to its simplest form. Here we have the binomial 6x squared plus 9x. So the first step will be to create a prime factor tree for each term. So the first term is 6x squared, and the second term is 9x. And the prime factor tree is just breaking up the expression to its smaller parts. So what could we have multiplied to get 6x squared? Well, obviously, we multiply 6 times x squared. So now we've got like a number side and a variable side. Let's go ahead and continue to factor the number side. So two numbers that multiply to give you 6, other than 6 in itself, 3 and 2. So now we've got prime numbers. 3 and 2 are prime numbers, so we're done with the number part of this. The variable part, very easy. X times x gives you x squared. So the expression 6x squared written out with its prime factors is 3 times 2 times x times x. So that's how you create a factor tree for an expression. So the same thing with 9x. So number 9 and obviously multiplied by x. X is already prime, and then further we can factor 9 because we know that 3 times 3 gives us 9. Now these are prime numbers. This 9 no longer matters. So let's write the prime factor for 9x. We've got 3 times 3 times x. So now the second step is to identify the common factors. Well, the common factors are the same numbers or variables that they share that are being multiplied. So if you look at both of them, you can see that both the expressions have a 3 that's being multiplied, and both the expressions have an x that's being multiplied. So the common factor for these two expressions is 3x. So that's what we're going to factor out. So we can rewrite the expression as 3x, so it's been factored out, and then in parentheses we're going to leave what's left after we factored out the 3x. So for 6x squared, what's left after we factor the 3x out? Well, it looks like it's just a 2 and an x. That gives us 2x. And then for 9x, what's left after we factor out 3x? It's just a 3. So we get the expression here, 3x times 2x plus 3. And the fourth step, this is actually our final answer, but the fourth step is just more of a check to make sure you did it correctly. So if we distributed this 3x back into parentheses, would we get our original expression? 3 times 2 is 6. X times x is x squared. 3 times 3 is 9. Times x is 9x. So we did. So we know that we factored it correctly. So I took a lot of time to kind of break this stuff down, and you're going to definitely want to factor tree to begin with, but after a while you get the feeling, and it becomes a little bit more natural, so it doesn't take as long. Okay, so we're going to factor this expression to its simplest form, and we've got a binomial 12x to the third power plus 18x to the second power. So let's go ahead and set these up for the factor tree. So we've got 12 and we've got x cubed, and we can continue to factor 12 to 6 and 2, and it doesn't really matter which way you go 3 and 4, but you're going to get the same prime factors in the end no matter what. And 6 becomes 3 times 2. And then when we factor out this x cubed, this is very easy. There's just 3x being multiplied, so we just know it's like that. So for 12x cubed, the prime factors are 3, 2, 2, and then 3x's. So 3 times 2 times 2 times x times x times x. And now for 18x squared. We got 18 times x squared. For x squared, we've got 2x's being multiplied. For 18, let's just say 2 times 9. And then for 9, 3 times 3. So for 18x squared, the prime factors are 3 times 3 times 2 times x times x. So now our second step is to look for common factors. So both of them have a 3 that's being multiplied, so we can go ahead and pull 3 out. And both of them have a 2 that's being multiplied, so we can also pull 2 out. And then they both have 2 x's that are being multiplied. They've got 1, 2 here, and then there's 2 x's being multiplied up here. So we can go ahead and pull all of this out. So when we do that, what we have on the outside is 3 times 2 times x, and I'm going to simplify this multiplication, just showing you that's how you pull it out. And then in parentheses, for 12x to the third, what's left is a 2 times an x, so we've got 2x left in here. And then for the 18x squared, we've got just a 3, so plus 3. And so now when I put this into Schoology for my final answer, I'm going to multiply the common factor together. So I know that 3 times 2 is 6. And I know that x times x is x squared. So that's the factor that we pulled out. We pulled out a 6x squared. In parentheses, we leave the 2x plus 3. If I multiply this back in, I should get the same answer of the original expression. 2 times 6, or 6 times 2 is 12. X squared times x is x cubed. 6 times 3 is 18. Times x squared is x squared. So we get the same exact as the original expression, which means we factored it correctly. Example number 3. So here we have 5x to the fourth power plus 5x to the third power. So 5x to the fourth and 5x to the third. So a lot of you guys have already identified that the common factor for the number part of this is 5, and you are absolutely right. 5 is a prime number, so we can't further factor 5. We just have 5 times x to the fourth, and then obviously there's 4 x's being multiplied. Here there's 3 x's being multiplied. So how many x's being multiplied do they share? Well, obviously, if this one has 4 and this one has 3, they both have at least 3 that are being multiplied. But I'll go ahead and write this out for you. So 5x to the fourth, prime factor is 5 times x times x times x times x. And then for the second term, we've got 5 times x times x times x. So what do they share? Well, obviously they share the 5, and then they share 3 x's. They both have 3 x's that are being multiplied. So let's go ahead and write our final answer, or our reduced answer. So we can go ahead and multiply these 3 x's together and say 5x cubed is what we're factoring out. And then in parentheses, for the first term, we just have an x left over, 1x, plus, and then you're probably wondering, what's left over here? Well, we factored out the entire term. So we're just going to put 1 here, because when we multiply this back in to check our answer, and this is our answer right here, sorry. When we multiply this back in to check our answer, 5x to the third times x is 5x to the fourth, plus 5x to the third times 1 is 5x to the third. So if what you factor out is the entire term, then you're just going to leave a 1 in there, so that way when it gets multiplied back in, it's multiplied back in as itself. Example number 4. So here we have 2x plus 5, or 2x to the 5th power, sorry, and we've got 7x squared. So prime factor, well, 2 times x to the 5th. 2 is a prime number, we can't further factor that. And then we've obviously got 5x's being multiplied here. And then here we've got 7 times x squared, and then we've got 2x's being multiplied here. 7's a prime number, the only numbers that multiply to 7 are 7 and 1. So our factor for 2x to the 5th is 2 times x times x times x times x times x, that's 5x's, and for 7x squared we have 7 times x times x. So the common factor for these two terms is they don't have a number that we can factor out, but they've got some x's, so it looks like we can factor out 2 x's. So we can write our answer as x squared, which we factored out, and then left in parentheses for 2x to the 5th is going to be 2 times x times x times x. So we've got 2x to the 3rd plus, for the 7x squared, all that's left after we factor out x squared is just 7. And this will be our final answer. When we multiply this back in, we get 2x to the 5th plus 7x squared. Now for the last example for today, our expression is x squared plus 6x. So let's go ahead and create the prime factor tree for x squared. So x squared, we know, is just x times x. There's no number or there's no coefficient here. And then for 6x, we've got 6 times x, and for 6 we've got 2 times 3. So this may seem a little redundant, and that's fine if it is. Hopefully by now you can kind of do some of this stuff shorthand. So we've got x times x, and then for 6x, we've got 2 times 3 times x. So you can see here that they don't have any numbers that we can factor out, coefficients, but they've got a variable. They've just got one x that's being multiplied in both of them. So let's go ahead and factor out that 1x. We factor out that 1x, and we don't need to write 1x. The computer knows that it's 1x if we just type in x. And then in parentheses, for the first term, what's left is just another x. So we've got x plus 2 times 3 for the second term, which is 6. And we know that if we distributed this back into the parentheses, we'd get x squared plus 6x. And that is our original expression, so we factored out correctly. Good luck on the homework.